All right, today we're tackling a notoriously tricky programming problem called burst balloons. Now, the goal is simple: get the most points, but the obvious way to do it will lead you straight into a trap. The secret? It's all about a brilliant mental flip that completely changes how you look at the problem. Let's dive in.
So here's the game plan. First, we're going to lay out the rules of the game. Then we'll walk right into the most common trap and figure out exactly why it fails. After that, we'll uncover the one key insight that cracks this whole thing wide open. We'll use that to build our solution, see the code in action, and wrap up with a powerful reverse thinking trick that you can use on all sorts of other problems. Okay, so what exactly is this game we're playing? Let's break down the rules.
The goal seems simple enough. You've got a row of balloons, each with a number on it. Your job is to pop them all, one by one, and figure out the perfect order that gets you the absolute maximum number of coins.
Okay, so here's how you get points. When you burst a balloon, the coins you get are its value multiplied by its neighbors on the left and right. So if we pop the 1, its neighbors are 3 and 5. That's 3 times 1 times 5, 15 coins. Now once the 1 is gone, the 3 and 5 become neighbors. But what about the ends? Well, we just pretend there are imaginary balloons with a 1 on them outside the array. As you can see, if we follow the specific sequence, we rack up a grand total of 167 coins.
All right, so what's our plan? The most intuitive thing to do is to be greedy. Make the move that looks best right now. But as we're about to find out, that simple logic is a total trap.
I mean, it seems kind of logical, right? Maybe we should pop the balloon with the smallest number first, like the 1 in our example. The thinking is, let's get rid of the low-value balloons so we can keep the big multipliers like 3, 5, and 8 around for longer. Makes sense, but does it actually work? Nope. It turns out that strategy is a dead end. Following that simple greedy path gets you a score of 78, which is less than half the best possible score of 167. This huge gap is a massive clue. Just making the best local choice at each step is not going to cut it. There's something much deeper going on here.
And here's the heart of the problem. When you burst a balloon, you're not just getting points. You are fundamentally changing the structure of the game. Balloons that were far apart are now suddenly neighbors. This means every single choice you make is tangled up with every future choice. The very first balloon you pop changes the entire scoring landscape for the rest of the game. So if thinking about the first balloon to burst just leads us down the wrong path, let's try something completely different. What if we think about the last one? This right here, this is the breakthrough moment. We need to stop asking, what should I pop now? And instead start asking, within any group of balloons, which one is going to be the absolute last one standing? So why on earth does this work? Well, think about it. If you decide which balloon in a certain range is going to be the very last one to pop, you instantly know what its neighbors are going to be when it finally bursts. They're the boundaries of that range. And this is the magic key. All the balloons to the left of your last balloon become one independent puzzle, and all the balloons to its right become another. We've just broken the chain of dependency that made this problem so hard. Okay, with this incredible reverse thinking insight, we can finally build a reliable step-by-step solution using dynamic programming. We're going to solve this using a table. Let's just call it F. Each little box in this table, let's say f of ij, is going to store a very specific piece of info, the absolute maximum score you can get by bursting all the balloons between boundaries I and j. Think of I and j as temporary walls that we're not touching yet. This formula looks a little scary, but it's the engine of our whole solution. All it's saying is this: to find the best score for the range from I to j, we test out every balloon k inside that range as being the last one to pop. For each possibility, the score is just the best score for the left subproblem, plus the best score for the right subproblem, plus the points we get from that final pop of k. We just run through all the k's and take the biggest number we find. So we fill this table out from the bottom up. We start by solving the tiniest possible ranges first, like a range of length 3 with just one balloon to pop. Then we use those answers to solve for slightly bigger ranges, and then bigger ones, and so on. Since we've already calculated the best scores for the smaller pieces, we can just look them up. We keep expanding outwards until we fill that final box, which gives us the answer for the entire array. All right, enough theory. Let's see how this logic actually translates into a working algorithm. The code is pretty much a direct translation of our strategy.
First, we add those imaginary ones to the ends of our array to handle the boundaries. Then we start looping through subarray links, going from small to large. For each subarray, we have another loop that tries out every balloon K inside as the potential last one. We apply our formula, find the max score, and store it. After all the loops are done, our final answer is just sitting there waiting for us. And when the algorithm runs its course on our example, 3158, it correctly lands on the maximum possible score, 167. A beautiful, satisfying result.
So let's step back for a second. What's the big lesson here? Because it's about way more than just this one problem.
The crucial takeaway is this powerful problem-solving technique. When you're stuck on a problem where every move you make seems to mess up all your future plans, try flipping the whole thing on its head. Stop thinking about the first step. Start thinking about the final one. Often, this is the key to breaking the dependencies and finding a much simpler path forward. This technique goes way beyond bursting balloons. You could apply this to game strategy, planning complex projects, all sorts of things. It's a fantastic new tool for your mental toolkit. So, the next time you're stuck in a tangled mess where every move feels wrong, just stop and ask yourself, what happened